Now let's take a look at these two examples. We have to convert both of them to scientific notation. Please notice that we do not have multipliers over here. We said that multiplier will help us to solve this problem. That's why I'm going to use it. I'm going to write 10 to 0. Remember, 10 to 0 is equal 1. 1 times this number is the same number. Now, we said that anytime we want to express the number in scientific notation, on the left side of the decimal point, I'm supposed to see number 1 from 1 to 9. Right now I have 0. So what I'm going to do, I'm going to move my decimal point 1, 2, 3, 4, 5, 6 times. Now, my number got bigger because I moved my decimal point to the right. Got bigger, and right now is 2.87. And when my number is getting bigger, exponent gets smaller. So I have to start from here. I move my decimal point 6 times. 1, 2, 3, 4, 5, 6 times. That's why I'm going to have exponent negative 6. And this is the solution to this problem. Let's take a look at this example. Now we have 48 millions. We are not seeing yet the decimal point. Remember, the decimal point is always at the end of the number. Make this decimal point always visible. We do not have multiplier. Okay, just add 1. Now the definition says that I'm supposed to have number from 1 to 9 on the left side of the decimal point. Right now I have 48 millions. It's a little bit too much. So I'm going to move my decimal point 1, 2, 3, 4, 5, 6, 7. I have 4.8 times 10 to 7. Now my number got smaller. Before I had 48 millions. Right now I have 4.8. When number gets smaller, exponent has to get bigger. I moved 7 times, that's why I have 7 over here. This is the solution to my problem. If you have difficulties with seeing that, just look at the number line. Okay, we start from 0 and we're supposed to increase the exponent 7 times. 1, 2, 3, 4, 5, 6, and we have 7 over here.